Jimmy invests $19,000 in an account that pays 8.91% compounded quarterly. How long in years and months will it take for his investment to reach $24,000? So first thing I want to focus on is some wording in this problem that indicates the formula that we're going to use. The interest is compounded quarterly, which means that the interest is compounded periodically. So I have this formula for periodic compound interest, and the formula is A equals P times 1 plus R over N to the NT. And the values in this formula are as follows. The P stands for principal, or the initial investment. R stands for the annual interest rate. N is the number of compoundings in 1 year. What that means is how often the interest is added into the account. So the number of times interest is added in 1 year. T is time in years, and A is the accrued amount, the amount after some period of time. So what I want to do is read through the problem again, and as I read through it, try to identify the values of the variables that we use in this formula. So as we start reading, it says that Jimmy invests $19,000 into the account. This is going to represent his initial investment. And so we're going to let $19,000 be P. So P is the principal, the initial investment. In an account that pays 8.91% compounded quarterly, 8.91% will represent the interest rate, which is R. So that's 8.91%, and we don't write this as a percentage when we use it in the formula. We put it in its decimal form. So I'm going to move that decimal point 2 places to the left, and the decimal form of 8.91% is 0.0891. So going back to that percentage, 8.91% compounded quarterly. Quarterly tells me how often the interest is added into the account. So it will be quarterly, and that's also an indication of the value of N. So if we compound quarterly, interest will get added 4 times per year. So the value of N will be 4. How long is a question, and that's an indication that the variable time is our unknown value and the value that we are trying to figure out. So T is time, and we don't know the time, and hopefully once we get all the information, we'll be able to solve the equation for time. How long in years and months will it take for his investment to reach $24,000? So this is the amount of money that we would like to have in the account after a period of time, and that is our accrued amount. So the value of A will be $24,000. So as I look at my formula, I'm going to check off the values that I have. I have a value for A, the accrued amount, P, the principal, R, the interest rate, N, the number of compoundings per year, and N again. And the only value I don't know is the value of T, time. And so because I know all of the variables except for what I'm looking for, I'll be able to create an equation and solve that equation for the missing value. So let's substitute the values in, and that would give the equation 24,000 equals 19,000 times 1. I'm going to write this again and give myself just a little bit more space. Okay, so we have 24,000 equals 19,000 times 1 plus 0.0891 over 4 to the 4 times t. So I have an equation which I'd like to solve, and I notice that my variable is in the exponent. So I'd like to use my strategies for solving exponential equations to solve this. Before I do that, I think it might be nice to simplify what we have in the parentheses, since all of those are numbers. So let me grab my calculator and we'll simplify that portion. Inside the parentheses, we have 1 plus 0.0891 over 4. So that gives 1.02275. So now I have the exponential equation 24,000 equals 19,000 times 1.02275 to the 4t. Now when you solve exponential equations, the first thing that you should do is isolate the exponential portion. We want that to be the only thing on one side of the equation. So I'm going to divide both sides by 19,000. That quickly, if we're able to cancel out these powers of 10, gives me 24 over 19 equals 1.222, oops, I left off a 0, 1.02275 to the 4t. Now I'll use the strategy of solving exponential equations, and there's two strategies that we typically use. We either convert to a logarithm or take the natural log of both sides. I'm going to take the natural log of both sides so that it will be easy for me to type into the calculator once we get to the end. I'm going to do natural log of 24 over 19 equals natural log of 1.02275 to the 4t. And now that I've introduced the logarithm, I can use a property of the logarithms called the power rule, and it allows me to move that power into the coefficient. So that gives natural log of 24 over 19 equals 4t, natural log of 1.02275. And now I'm going to isolate t by dividing both sides by 4 natural log of 1.02275. So now we have our answer for time. Natural log of 24 over 19 divided by 4 natural log of 1.02275. We're going to type this into the calculator, and before we do that, I just want to remind you that the question asks you to put this in years and months. When we put it in the calculator, it will be initially in only years, and we'll have to do a conversion to put it in months, years and months. So in the calculator, we have natural log of 24 over 19 divided by, and I need parentheses around my whole denominator, 4 times natural log of 1.02225. I'm going to close parenthesis for the log and close parenthesis for the denominator. So that's going to give me 2.651 and some more decimal places. I'm going to write 2.65 down. But because I'm going to do a little bit of converting here, I'm going to try to keep all of the decimals in the calculator here. So as I look at this, this is in years. And if I take the 2, that's going to be 2 years. And I'm going to take this portion to help me figure out how many months I have. So that's 0.65, which is more than half of a year. So we know it's going to be more than 6 months. But let me show you how in my calculator I'm going to figure this out. So first off, I'm going to subtract 2 from the answer because I'm not concerned about the years portion. I'm only concerned with the months. And in order to convert this in years to months, I have to know how many months are in a year. There are 12 months in a year. So I'm going to be able to multiply this value by 12. And that converts this to months. And since we have another decimal answer here, and it only wants it in years and months, I think I'm going to round up to 8 months. So I've got 7.8 months, which I'm going to round up to 8 months. We have 2 years and 8 months is how long it takes for $19,000 to grow to be $24,000. So after rereading the directions on this problem, I wanted to come back and modify our answer just a little bit. So if you recall, in the beginning of the problem, it's mentioned that our interest is compounded quarterly. And that's an indication of how often the interest is added into the account. So just to explain it in a little bit more detail, let's think about the first few months of the existence of our account. We make an initial investment of $19,000. So in the first month, we're going to have $19,000. In the second month, we have $19,000. And then in the third month, we're going to have our interest payment added. That's going to be $19,000 plus whatever that interest calculation is going to be. So when we consider our problem, we came up with an answer of 8 months, but that's a month where interest wouldn't be added. So if we write out the months of the year, we would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And because we're compounding quarterly, interest is going to be added in months 3, 6, 9, and 12. And so when we're trying to decide when the balance will reach $24,000, like in this problem, it can only occur on those months where interest is being added in. So we're going to round this 8 months up to 9 months so we can more align with the construction of this example. So it would take 2 years and 9 months for the balance of $19,000 to grow to $24,000. Thank you for checking out my videos. Have a great day.